Now, in continuation of wave optics, next topic is time independent Schrodinger equation. Now, we know that psi is equal to a e raised to power minus iota upon h cross et minus px. Psi is the function of e and p. Then e raised to power minus iota e upon h cross t and e iota p upon h cross x are the time dependent and position dependent function. Differentiating equation number 9 with respect to t, then we get delta psi upon delta t is equal to iota e h cross a e की power minus iota e h upon t phi x. And with differentiating equation number 9 with respect to x twice, and we get del square psi upon delta x square is equal to a e की power minus iota e upon h cross t del square psi upon del phi upon delta x square. We get equation number 11. Using equation number 10 or 11 in equation number 7, and we get e phi is equal to minus iota h square upon 2m square del square phi upon delta x square plus v phi. Equation number 12. Write down in equation number 12 in 3-dimensional box, then we get minus h square upon 2m del square phi plus v phi is equal to e phi. This is the time dependent independent Schrodinger equation. The next topic, particle in 1D box. Particle in 1D box. Let a particle be restricted to move in one dimensional within a certain region from x is equal to 0 to x is equal to infinity. The potential function Vx can be defined as follows: Vx is equal to infinity, limit x is less than 0 and greater than L, and 0 between 0 to L. Now we know that from Schrodinger equation, del square psi upon delta x square plus 2m upon h cross square e psi is equal to 0. Since psi is a function of x only, the partial derivatives can be replaced by total derivatives, that is d square psi upon dx square plus 2m upon h cross square e psi is equal to 0. Now, where alpha is equal to under root 2me upon h cross square. The general solution of equation number 3 can be given as psi is equal to a e की power iota alpha x plus b e की power minus iota alpha x, where a and b is constant. The probability of finding the particle at wall at x is equal to 0 and x is equal to L is 0. That is psi is equal to 0 and x is equal to 0 and x is equal to L. From equation number 5, we get a plus b is equal to 0, then b is equal to minus a, and using x is equal to L, then a e की power iota alpha L plus b e की power minus iota alpha L is equal to 0, a e की power minus iota alpha L minus a minus iota alpha L is equal to 0. Then we get 2 iota a sin alpha L is equal to 0. We know that a is not equal to 0, therefore sin alpha L is equal to 0. Alpha L is equal to n pi, where n is equal to 0, 1, 2, 3, 4. Now, psi is equal to a e की power iota alpha x plus b e की power minus iota alpha x, then we get psi is equal to 2 iota a sin alpha x. Now, psi is equal to a dash sin alpha x, where a dash is equal to 2 iota a. Then function of psi is equal to a dash sin alpha n pi upon L x. We get equation number 8. Since the probability of finding the particle within a box is unity, we have limit 0 to L psi x or conjugate of psi x is equal to 0, then solve, and we get value of A dash is equal to under root 2 upon L. Therefore, from equation number 8 and 9, we get a wave function of particle in 1D box is psi n is equal to under root 2 upon L sine n pi upon L x. Wave function for a particle in a 1D box. Eigenvalue from equation number 4 and 7, alpha L is equal to n pi, then alpha is equal to n pi upon L. We know that alpha is equal to under root 2 me upon h cross square is equal to n pi, then solve, we get En is equal to n square pi square h cross square upon 2m L square, where E is represented eigenvalue of 1D box. Then E equal to n equal to 1, we get h square pi square upon 2m L square, and similarly the wave function is represented, and probability density is also represented in figure.